Good day, everyone. So we are from OCC3, Group 4, and our project title is Big Data Analysis of Airbnb Accommodation Pricing and Tourism Demand. So this project is under the Tourism and Hospitality category, and it also related to the SDG Act, which is Decent Work and Economic Growth. So our group consists of 8 members, and each of the member are contributed to different parts of the project, including the research, dataset preparation, hive analysis, part analysis, visualization, report writing, and also the presentation. So next. Okay, so for the introduction part, the Airbnb is now an important platform in the tourism and the hospitality industry, which it allows the host to offer the short-term accommodation while travelers can compare the different listing based on the price, location, room type, and reviews. However, the Airbnb pricing is not always simple to understand because the platform includes many types of the hosts, such as non-professional hosts, and more traditional accommodation providers. Because of this, the price of Airbnb listing can be affected by many factors. So in this project, we will focus on the 2 main areas, which is the accommodation pricing and tourism demand-related patterns. So the pricing is important because the host will need to set the competitive prices, while the travelers also need to compare the prices before making a booking. So at the same time, the tourism demand is not directly shown in the data set, so we will use the indirect indicators such as the listing concentration and review related information to understand the market activity. Since the data set is too large, we use the big data tools such as the Hive and the PySpark to process and analyze the data. So these tools will help us to identify the patterns that may not be easy to observe from the raw data set alone. Moving words to the problem statement. So and also the objective. So we have 3 main problem statements. So first, the Airbnb dataset contains a large volume of the dataset, and it needs to proper processing using the big data tools. So we also want to compare the runtime performance between the Hive and PySpark. Second is the Airbnb prices may vary across room types, cities, and neighborhoods. Without the structured analysis, these pricing patterns are not clear. Lastly, is the tourism demand cannot be observed directly from the dataset. Because of that, we will use the listing count and geographical distribution as indirect indicators of tourism demand related patterns. So based on this problem statement, our first objective is to process the Airbnb data using the Hive Spark or PySpark, and then we will compare their runtime performance. And then our second objective is to identify the pricing patterns based on the room type, city, and neighborhood. And lastly, our objective is to examine the demand-related patterns using the listing count and geographic distribution as indirect indicators. So that is the background and direction of our project. Next, my group mate, Wingwai, will explain the tools and the technical processes using the analysis.
Thank you, Lydia. To achieve this, we deployed a specific tool stack. So Apache Hive was used for structured data storage and SQL-based querying. So PySpark was deployed for fast data pre-processing, analysis, and runtime benchmarking against Hive. So finally, our Power BI was used to present our results through interactive charts in dashboard and summary table. Next. So our dataset contained nearly 280,000 listings and over 5 million reviews. So cleaning this data was critical to ensure accuracy. First, we dropped features with excessive missing values such as the district columns. Next, we imputed host response times with the value unknown, few missing numerical scores using the medians to avoid bias, and reformatted dates into proper time series format. So this pre-processing step ensured that our analysis was reliable and free from distortions caused by missings or inconsistent data. Next. So using Hive, we ran SQL queries to look at Airbnb pricing and demand. When we compare prices by room type, we saw that hotel rooms were the most expensive on average, while entire place had the largest number of listings. So looking at cities, Paris, New York, and Sydney had the highest numbers of listings overall. So for average price by city, Bangkok, Cape Town, and Mexico City came out on top. Thus, we need to remember that currency differences affect this result. So at the neighborhood levels, Rome's Central Historical had the biggest concentration of listing. So Hive gave us clear insights into these patterns, but the queries took quite a long time to run. Next. So to compare performance, we ran the same data queries using the PySpark data frame API. So PySpark works in memories and uses distributed computing, which avoids the slower disk operations than Hive relies on. So as a result, Spark finished all queries in just 0.5 to 1.2 seconds, much faster than Hive. So most importantly, PySpark gave exactly the same results as Hive, which confirmed that our data processing was accurate and reliable. I will now hand in over to Ivan for the visualizations to conclusion.
So for visualization, we use Power BI to turn technical outputs into a decision-ready insights. Hive and PySpark gave us the number, but Power BI helped us to see the story behind the numbers. So in one dashboard, we can compare total listing, the average price, the city concentration, the neighborhood pricing, and also the room type differences. Here, the city slicer also make the dashboard interactive. So user can explore patterns by location instead of just reading at the static tables. So in short, this dashboard shows a bigger picture, where the Airbnb supply is concentrated, which areas are more expensive, and how the room type affects pricing. Moving on to our result and discussion. First, room type matters. Entire place dominate the listing volume, but hotel room has the highest average price. This shows that the supply and price premium are driven by different factors. Second, Airbnb supply is highly concentrated in major cities such as Paris, New York, and Sydney. However, the listing count shouldn't be treated as a tourist demand. It is better to understood as an accommodation supply and the platform activity. Third, the neighborhood pricing varies significantly, showing that the micro location matters. However, because the data set covers multiple countries and the prices are not standardized into just one currency, so very high values may reflect local currency differences rather than a truly higher accommodation cost. Finally, PySpark was much faster than Hive of around 0.5 seconds compared to about 30 seconds. But this should be treated as an experimental benchmark, not a universal result. Next. So to conclude, we achieved all three objectives. Hive and PySpark produced consistent results, with PySpark performing much faster in our experiment. We also found that the room type and location are important factors in Airbnb pricing and listing distribution. So for future improvement, price should be standardized into one currency for fair cross-country comparison. This dataset can also be used for sentiment analysis to understand guest satisfaction, and the performance test should be repeated in a real distributed Hadoop cluster. So overall, this project shows how big data tools can turn large Airbnb dataset into a useful pricing and market insights. That's all from us. Thank you.